This is the first video of a series about training your own AI denoise model and use it with Darktable 5.6. In this video, we will do the setup and then we will do a smoke run using the run-in dataset. The goal is simple. Before we take time taking our own pictures, we want to confirm that the training setup is working. In next week's video, I will show you how you can take your own picture to create your own dataset, and then I will show you how you can train your model using your own dataset. And the third video will be about importing your own model in Darktable 5.6. So if that sounds good for you, let's go. Okay guys, so the raw denoise in Darktable 5.6 will use raw-nin. And this repository is the source code that was used to train raw-nin. And by using it, we should be able to train our own raw-nin model. So today what we will do is we will try to use this repository to train raw-nin locally on our computers. To do that, we will use the raw-nin dataset, so we won't use our own pictures. But in another video, I will train it using my own pictures. And I will show you the process so you can replicate it yourself. And once our model will be trained, we will be able to import them in Darktable 5.6. So we will be able to denoise pictures using our own model. Crazy stuff. So before you start, you make sure you have a lot of space on your hard drive. So if I look at mine, I have 3.4 terabyte available. When I tested everything earlier, I believe it uses approximately 600 gigabytes. So make sure you have enough space, so maybe 1 terabyte or something like that. Okay, so the first step is to clone the Git repo. So we can go there. I will put the link in the video description. So we do git clone. We paste that, and I will name the folder run-in. Oh, whoops, sorry, I forget something. CD. So now I'm inside my hard drive. So I do my git clone run-in. That's it. So I clone the repository. Then I do my cd run-in git, and I'm inside the repo. So for this project, I assume you already have git installed as well as UV. If you don't, links are in the description. So now I do UV, VE, VE and V to create the virtual environment. And I have the Pi project, so I will do UV pip install -e dot. So when you run that, you will get this issue. So I have no idea what Darktable Python is, and we won't need it. From what I understand, they are Fuji raw file in the dataset, and they are converted using Darktable before cropping for training. But during training, they are not being used. So instead of spending time converting them, we will just disable Darktable Python and we won't convert anything. So what you have to do now is edit the file using Nano. So you open the file, and right there, you remove Darktable Python. So with Nano, you do Control-K, and that's it. The line has been removed. I will just check, make sure I didn't forget anything. Oh, yes, you can remove everything there. So all these lines, you remove it. So you only have the dependencies. Yeah, you have the few lines there. You have the dependencies without Darktable Python, and you remove everything after the bracket. Then you do Control-X, Y, Enter, and that's it. So now if you do your UV pip install -e dot, it should run. That's it. Everything has been installed. Now what we have to do is download the dataset. So to do so, you use this command. So you will, using bash, you will run that script which will download the dataset. So if you want, you can also inspect it with Nano to see what the script is doing. Basically, it will download all the picture from this website. So again, now I can start downloading everything. So as you can see, it will download them one by one. So now we have the first image that was downloaded, the second, and so on. So I believe there is about 100 gigabytes to download, so it will take time. Okay, everything has been downloaded, and with my connection speed, it took roughly 5 hours. Now everything was downloaded inside this folder. So if we look the size, we downloaded 112 gigabytes of pictures. And make sure you have enough space on your drive before you do that. Now we will run this command to check the number of files we downloaded. So we downloaded 2,846 pictures total. And when we look at the file's name, they all follow the same structure. So for example, at the beginning, we have the sensor type. Then we have a description of what's inside the picture. And then we have the ISO. If, for example, we look the yellow rock, we see we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 pictures of the same scenes at different ISOs. Now that we downloaded everything, we can run this command to organize all of our pictures. We need to do that because the cropping and the training script expect the picture in a specific format, so we need to organize everything. As you can see, it's completed and all files have been moved to dataset-runin-src. So if we have a look, you see that the pictures have been classified between Bayer and X-trans sensors. So if we look at Bayer, and then each scene is inside a specific folder. So if, for example, I do wool basket, you see I have all my files there. So this specific scene has 12 pictures with different ISOs. And as you can see with this command, it means we have 197 scenes for the Bayer sensor. And that's what we will use for training. So we won't use the X-trans sensor for training. I think if you want to use them, it's possible, but you need to change something in the script to include them. And just so you know, there are 115 scenes for the X-trans sensor. Okay, now we will run the script to crop all these images. We need to crop everything because we won't train the model with full images. Doing that would require too much VRAM. So instead, we make many patches, and then each patch are fed to the model for training. So by using smaller patch, it consumes less VRAM. And all these patches will take a lot of space. So I will check what space I have available now on the drive, and then once everything is cropped, I will check it again so we can see the difference. Right now, as you can see, I have 119 gigabytes used on the drive. So I will start cropping everything. To do that, I will cd to src run in. From there, I will run this command. So we will run the Python script called crop_dataset.py. I'm not sure what that is, what this warning is, so I will double check. Okay, because of the warning, I think it's better to run this command. So with the UV link mode equal copy. I'm not sure what this is doing, but I think it's better. Yeah, so no warning, so that's good. So I'm not sure how long this will take, so I will just stop there and get back to you once everything has been cropped. Okay, so the cropping is completed. I'm not able to show you the log because my computer crashed, but trust me, everything worked perfectly. In fact, if we run this command, we will be able to see our disk usage. So if I remember correctly, we were at 119 gigabyte before, and now we are at 576. Roughly, we got an additional 450 gigabyte by cropping everything. So before you run it, make sure you have enough space on your computer. Now, if we look in Dataset, run in, there should be a new folder named crop. Yeah, so now all of our cropped images are inside this folder. Now that we have all of these cropped images, we need to align them. To do so, go back to run in. Yeah, go back to this folder and run this command. Again, this will take some time, so I will stop the video and get back to you shortly. Just so you know, when I run the cropping, it took roughly 2 hours. So depending on the speed of your CPU, it might be faster or slower. It depends. Okay guys, so it's currently almost 1 p.m. and it's still running. So I think I've been running this for, yes, 4 hours. So I'm tired, so I will just go to sleep and get back to you tomorrow once everything has been aligned. Okay, good morning. So according to the log, it took 5 hours to run everything, but I just realized I set it to run with 2 CPU threads, so that's probably why it was slower. So if you want to do something faster, just remove this from the command. If we look at the space, now we are using 577 gigs, but I don't remember what it was before. I had a look and we created this folder. So we added 1.1 gigabyte, and in this folder we have a lot of PNG files. And we have also created this file, so running mask and alignment.yaml, which is 45 megabyte. And now we are ready for training. So instead of running a full complete training, we will just run a smoke test just to confirm everything is working properly. So we will run this command. Okay, so while it's running, I'm monitoring NVTop, and we can see I roughly have 1.5 gig of VRAM being used by the training script. Okay, I think it's done. Okay, so we have our PyTorch model right there. So if you want to see where yours are saved, just go there and you will see the folder path right there. Just so you know, the device 0, that's my GPU. So in your case, it may vary a little bit. Because this was a smoke test, we only did 100 steps, and we did the validation every 50 steps, so twice, I guess. But when we will run the real test, it will do 6 million steps, so it will take much longer. And validation and testing, validation will be every 15,000 steps, and test will be every 1.5 million steps. So just for fun, I will check how long it will take on my system. Okay, training was completed in roughly 2 hours and a half, so it took 157 minutes to complete everything. At this speed, it means that if I train the 6 million steps like in the configuration file, it will take 65 days. So my model is in this folder, so it's the 4channel-3. And in that folder, there is a YAML file with the test results. So we will open it. So what we see there is that the best step was 3000. If we look at 3000, we can see the test result. So MSE is the error. So a lower number is better. So when we look at the training data, MSE started relatively high. So right now I'm at .0012, then .0006, and then it continued to go down. And then at 3,500, it started to increase. Yeah, so that's why the best one is 3,000. What this is telling us is that it may not be a good idea to train during 6 million steps. So maybe that value was put there randomly just to make sure we have a high number, but probably there is no need for training up to 6 million. So I believe I will do some tests in the next few days and will keep you updated in the next video. If you have any idea about that, let me know in the comments. But anyways, at this stage, everything is working, so we are able to train, but that's not what we want to do. So what we want to do is to train the model using our own data. So in the next video, so part 2, I will share with you how to take the pictures and then how to organize them for training. So that's it for me. See you next time.